Have you ever been at a work meeting or maybe a dinner party and someone brings up the latest thing artificial intelligence can do and a colleague just rolls their eyes, sighs, and says, well, it's just a stochastic parrot.
Oh, yeah. It instantly kills the conversation.
Right. You hear that phrase, people nod sagely like this profound truth was just dropped, and suddenly the debate is just over.
It really is the ultimate intellectual trump card in tech circles right now. I mean, it paints a technology as nothing more than a mindless mimic. But the problem is, while it sounds incredibly sophisticated, the vast majority of people dropping that phrase into casual conversation, they have no idea where it actually came from.
Yeah, they don't know the specific, highly technical warnings the original researchers were raising when they coined it back in 2021.
Exactly. And they
Yeah.
certainly aren't applying it correctly to modern systems.
Which makes it the perfect mystery for us to unravel today.
Mm-hmm.
So, welcome to the deep dive. We are putting two distinct eras of AI criticism head to head.
Should be
So, on one side, we have that foundational 2021 academic paper, the one that actually birthed the stochastic parrot concept. It was written by Emily M. Bender, Timnit Gebru, and their colleagues, and it was warning us about the catastrophic environmental and social risks of building massive language models.
And then on the other side, we have a highly provocative modern essay from Jorge Garapier's.
Right, and Pyers is super interesting. He's an independent researcher and a science writer with a Ph.D. in bioinformatics. He runs a Medium publication called Computational Thinking, which is all about how computers think, decide, and learn. He's written series on AI, democracy, and critical thinking. He's a systems thinker who basically says that looking at the AI ecosystem of today and still calling it a stochastic parrot is, well, intellectually lazy.
Yeah, Pyers brings a really fascinating lens to this.
Oh,
With his background in computational biology and logic and programming, he analyzes AI not just as a piece of code, but as a complex system. So when he evaluates a critique, he's looking at whether the mental model of the critic actually matches the reality of the system they are criticizing.
okay, let's unpack this. I want to start with that 2021 reality. Because before we can understand why Pyers thinks the parrot label is outdated, we really have to understand why it was so utterly terrifying when it was first introduced.
We do. We're essentially looking at two snapshots in the history of technology here. One from before the massive generative AI boom, and one from today. And we're evaluating how well our criticisms have aged.
Right, so back in 2021, before ChatGPT was on every single smartphone on Earth, Bender and Gebru were looking at the trajectory of these models and asking, how big is too big?
And they weren't even talking about what the AI was saying yet. They were looking at the sheer physical reality of building the thing.
Yeah, the hardware.
Mm-hmm.
Because we have this terrible habit of using the word cloud to describe digital infrastructure.
Oh, I hate that word.
Right. It sounds ethereal. It sounds weightless. But training a massive language model is an intensely physical, heavy industrial process.
It really is. The 2021 paper focuses heavily on the staggering growth in the size of these models, which they measure in parameters.
I hear that word constantly. 1 trillion parameters, 100 billion parameters. But let's actually ground that for a second. What is a parameter actually doing inside the machine?
Okay, think of a neural network like a gigantic, incredibly complex mixing board in a music studio, but instead of audio, it's processing data.
Okay, a giant mixing board.
Right. The parameters are the millions or billions of individual knobs and sliders on that board. During the training phase, the computer feeds massive amounts of text through the system, and it painstakingly adjusts every single one of those knobs over and over and over again until the output matches the expected pattern.
So if I'm building a model, how many knobs are we talking about adjusting?
Well, the paper maps out an exponential explosion. So in 2019, a state-of-the-art model called BERT had about 340 million parameters.
Which is a lot of knobs.
Right, that was considered huge. But fast forward a little over a year, and OpenAI releases GPT-3 with 175 billion parameters.
Wow.
And then shortly after that, Google introduced Switch C with 1.6 trillion.
A jump from hundreds of millions to over 1 trillion. I mean, that requires an unimaginable amount of computing power to adjust all those knobs.
It does. And computing power is just electricity. It's specialized hardware. We're talking massive racks of graphics processing units or GPUs running at maximum capacity, generating enormous amounts of heat, requiring industrial water cooling literally for weeks or months on end.
So it's a massive factory.
Exactly. The 2021 paper pulls data from a study by Emmett Struble and her colleagues to quantify this. They looked at a process called neural architecture search. which is essentially using AI to help design the optimal structure for another AI.
Okay.
Training a single transformer model this way emitted roughly 284 tons of carbon dioxide.
284 tons. That is such a massive number. It almost loses its meaning. Like, how does that translate to everyday life?
Well, the paper puts it into a very stark perspective. Training just one basic foundational version of that 2019 BERT model requires roughly the same amount of energy as a trans-American passenger flight.
A cross-country flight.
Yeah.
Just for one model.
And remember, researchers don't just train a model once. They train it, test it, realize they made a mistake, tweak the data, and train it again. Every single iteration is another trans-American flight's worth of carbon being pumped into the atmosphere.
That drastically shifts how I view the companies building these things. The financial cost alone must be an incredible barrier. I mean, if you were burning millions of dollars in electricity just to run an experiment, it means only 3 or 4 mega corporations on the planet can actually afford to play the game.
Consolidation of power is a huge concern in the paper. But Bender and Gebru go a step further and analyze who actually bears the cost of that power. Their analysis points to a severe imbalance of harm, bringing up the concept of environmental racism.
Right, because the server farm pulling all that electricity might be in a wealthy tech hub in California, but the climate impact is global.
Precisely. According to the researchers' analysis, the negative effects of this massive energy consumption accelerating climate change, shifting monsoon patterns in India, devastating floods in places like Sudan, rising sea levels threatening the Maldives, those effects are disproportionately falling on marginalized, often impoverished communities around the world.
And here is the truly bitter pill the paper outlines. Those specific communities facing the flooding and the droughts, they're the absolute least likely to benefit from the technology being built.
Yeah, not at all.
The AI is optimizing English language parsing for people wealthy enough to own smart speakers and the latest laptops. It's a system that concentrates the benefits among the privileged while offshoring the environmental devastation to the vulnerable.
It is a profound structural critique. I mean, if a community in the global south is paying the environmental price for a technology that doesn't even support their native language, the foundational ethics of the entire enterprise are in question before the AI even generates its first sentence.
Yeah, that covers the physical cost, the hardware. But a mixing board, no matter how big, is completely useless without music to play through it. And for AI, that music is the training data. And the 2021 paper gets really intense when it looks at what we are actually feeding these machines.
It really does, because to train a model with 1 trillion parameters, you can't just feed it a few encyclopedias.
That's right. You need an ocean of text.
Exactly. The datasets discussed in the paper are almost unfathomably large. They talk about Common Crawl, which is essentially an automated bot just scraping web pages indiscriminately for years.
Just vacuuming up the internet.
Yeah, vacuuming everything. They mention a dataset literally called the Pile, which is an 800 gigabyte block of pure text.
Okay, to visualize 800 gigabytes of text, a standard novel is maybe a megabyte. So we were talking about roughly 800,000 books worth of random internet chatter, forum posts, and articles.
Which leads to a critical concept the authors call documentation debt. If a dataset is that massive, it is physically impossible for any human or even a giant team of humans to read it, audit it, and document what is actually in it.
You literally can't know what's in there.
Right. You are building the foundation of your artificial intelligence on a massive pile of information that you fundamentally do not understand.
Now, I can totally hear a Silicon Valley engineer pushing back on that, though. They would probably argue, look, we scrape the whole internet. The internet has billions of users from all over the world, so by scraping everything, we automatically capture the full, diverse spectrum of humanity. Problem solved.
Yeah, and the paper attacks that exact assumption, calling it the illusion of internet diversity.
The illusion.
Yes, because the sheer volume of data does not guarantee representation. Bender and Gebru analyze the demographics of who actually generates the text that ends up in these data sets.
Okay, so who is it?
Well, for instance, early models were heavily trained on outbound links from Reddit. The paper cites a survey showing that nearly 67% of Reddit users in the U.S. are men, and a vast majority are young, under 30.
And they looked at Wikipedia, too, which is basically the backbone of almost every AI training set.
Right. The researchers point to surveys indicating that only about 8.8 to 15% of Wikipedia editors are women.
Oh, wow, that is low.
So right out of the gate, you aren't capturing a mirror image of humanity. You are capturing a highly skewed demographic that leans heavily toward young, male, internet-connected individuals in developed English-speaking nations.
It's like, so building these models is like trying to map the entire ocean, but you're only dipping your bucket into the shipping lanes. You think you have the whole ocean, but you just have the busiest, loudest parts.
I really like that analogy. And the paper notes that the quiet ecosystems are often quiet by force. Marginalized populations, whether that's domestic abuse survivors, trans individuals, or visibly disabled people, they frequently face severe harassment on open, unmoderated platforms.
Yeah, the internet can be a really hostile place.
Exactly. And when that harassment drives them off the platforms, their voices, their vocabulary, and their perspectives are entirely erased from the data pipeline that eventually feeds the AI.
So the researchers draw a very stark conclusion from this demographic skew. And we want to be super clear here. We are looking specifically at Bender and Gebru's analysis of internet culture and data pipelines. We're just relaying their findings. They argue that because participation is narrowed by these systemic factors, the voices of those most likely to hold a dominant hegemonic viewpoint end up massively overrepresented in the training data.
Yes. Specifically in US and UK English datasets, they found that white supremacist, misogynistic, ageist, and ableist views appear at a frequency far exceeding their actual prevalence in the real-world population.
So the internet amplifies certain extreme dominant voices, and then the AI just ingests that amplified signal as if it were the baseline reality of human interaction.
That's exactly their point.
My immediate thought as a user, hearing about that level of toxicity in the raw data is just, well, fix it. If the raw internet is a cesspool, why can't the engineers just build a giant filter? Just run a toxicity spell check, delete the bad stuff, and you get a clean, polite AI.
And that brings us to one of the most fascinating paradoxes in the paper. The authors explore the deeply flawed mechanisms humans use to try and clean this data.
Why is it flawed?
They look at a specific massive data set called the Colossal Clean Crawled Corpus, or C4. The engineers working on it wanted to remove hate speech and pornography, which, seems perfectly reasonable.
Right. Nobody wants an AI spitting out hate speech.
So they created a block list of roughly 400 words they categorized as dirty, naughty, obscene, or otherwise bad words, and simply discarded any web page containing any of those words.
Okay, a blunt instrument approach. If a page has a banned word, throw the whole page out. What's the catch there?
The catch is that human language is highly contextual, and blunt algorithms don't understand context. The paper notes that this list of 400 words included terms related to sexual orientation, including reclaimed slurs like twink.
Oh, I see where this is going.
By automatically filtering out any page that used that word, the engineers inadvertently wiped out entire online spaces built by and for the LGBTQ+ community.
Wait, really? So in a misguided attempt to protect marginalized groups from hate speech, the algorithm actively silenced their actual discourse. The AI model never gets to see the positive community-building context of those identities because the filter just treated it all as obscene.
What's fascinating here is that the very tools we use to try and fix AI bias often perpetuate the exact same bias. You end up with an AI that only understands a highly sterilized corporate version of human existence, completely devoid of the complex ways real communities communicate.
That is wild.
And the paper goes further, pointing out that language is not a static thing. It evolves dynamically as society changes. They give the example of the Black Lives Matter movement.
Oh, how does social movement language play into AI training?
Well, the researchers analyzed how the BLM movement actively shifted narratives and vocabulary in real time. As the movement gained momentum, it directly influenced how Wikipedia articles about police shootings were generated, updated, and framed.
Right. Society changes how it talks about things.
Exactly. Social movements destabilize old dominant narratives by introducing new language and new context. But an AI model is trained on a static snapshot of the internet.
Oh, I see the problem. If you spend millions of dollars to train a massive AI on a snapshot of the internet from 2018, that AI's entire worldview is frozen in 2018. It doesn't know about the social movements or the linguistic shifts that happened in 2019 or 2020.
The authors term this value lock. Because it is so environmentally and financially expensive to train these models from scratch, you can't just update them every week to reflect new cultural nuances. The AI becomes trapped in a specific cultural moment.
So it's stuck in the past.
Yes, and if that frozen AI is then deployed across search engines, customer service bots, and writing assistants, it acts as a cultural anchor, dragging our societal baseline back to that older, less inclusive understanding of the world.
I'm trying to wrap my head around a technical solution here, though. If a static block list of 400 words is too blunt, why not use another AI to audit the data? We have algorithms designed specifically to detect toxicity now, right? Can't we just use a more nuanced tool?
You're touching on what the paper highlights as the ultimate broken ruler problem.
The broken ruler.
Yeah. The researchers examined tools like the Perspective API, which is widely used to automatically measure the toxicity of a given piece of text. But the studies they cite reveal that this API often mistakenly flags perfectly benign sentences as highly toxic, simply because they contain identity markers.
Give me an example of how that breaks down in practice.
So if you feed the API a sentence that includes the word blind or gay or Muslim, the toxicity score frequently spikes, even if the sentence is just a neutral statement of fact.
Why would it do that?
Because the auditing tool itself was trained on the same biased internet data.
Oh my gosh.
It learned statistically that those identity markers frequently appear in toxic arguments online, so it assumes the mere presence of the word implies toxicity.
That is maddening. The AI checking for bias is biased by the exact same data it's supposed to be cleaning up. But isn't it an impossible standard? If the data is unfiltered, it's toxic. If we filter it, we silence marginalized voices. Are the original authors arguing that these models are fundamentally unfixable at this scale?
That is the core of their argument regarding scale. They argue that when datasets reach hundreds of gigabytes of undocumented text, the risks become unmitigable. Their proposed solution is a radical step backward from the industry trend. They advocate for budgeting the time and money for careful manual curation.
Manual curation.
Yeah.
For the whole internet.
They argue researchers should only collect as much data as they can thoroughly document, understand, and account for.
Okay, so we've established the deep structural flaws the 2021 paper exposed regarding the data itself, the bias, the environmental cost, the impossibility of fair filtering. But if the data is this flawed, how are these models producing essays and answering questions that sound so incredibly smart? This is where we finally arrive at the exact definition of the stochastic parrot.
This is the philosophical heart of the 2021 critique. The paper argues emphatically that despite appearances, large language models are not performing natural language, understanding, what researchers call NLU. They are manipulating linguistic form entirely without access to meaning.
Form without meaning. I want to make sure I completely grasp that. The machine knows the shape of the word, but not the soul of it.
Let's look at the mechanics of what a language model actually does. At its core, it is a system trained on string prediction tasks. It looks at a sequence of words and calculates the statistical probability of what the next word should be, based on the billions of examples it processed during training. It is an entirely mathematical statistical exercise.
So it's playing the world's most complex game of Mad Libs.
Exactly. When the model outputs the word dog, it has no concept of what a dog is. It has never petted a dog. It has never heard a dog bark. It doesn't know that a dog is a living creature.
Right.
All it knows is that mathematically, the text token, DOG, has a highly probable statistical relationship with the tokens BARK and PET in its dataset.
But when I talk to another person about a dog, that's not what I'm doing. I'm not calculating the probability of my next syllable.
Right, and the paper draws a sharp contrast here. Human communication is what they call a jointly constructed activity.
Jointly constructed.
Yeah. When we converse, our ability to understand each other relies on common ground. We share a physical reality. Furthermore, we have communicative intent. I have a specific concept in my mind that I am actively trying to transmit into your mind.
And we're constantly reading each other. Right. If I explain something and you get a confused look on your face, I immediately pivot. I use a different analogy. I am modeling what is happening in your brain.
That is called theory of mind, and it is essential to human language. And AI has absolutely none of this. It has no mental state, no intent to communicate, and no model of your understanding.
It's just guessing.
It is a stochastic system, meaning randomly determined or governed by probability stitching together sequences of symbols. It is a stochastic parrot.
You know, it's like an incredibly talented actor reciting lines in a language they don't speak.
Oh, that's a good way to look at it.
Right. They know exactly where to put the inflection. They make you cry. They make you laugh. But they have absolutely no idea what they just said.
That is a beautiful way to visualize form without meaning. But the true danger, according to the paper, isn't that the parrot doesn't understand. The danger is that we are human.
What do you mean?
When a literal bird mimics the phrase, "I love you," we know it's a bird. We don't assume the parrot has emotional depth. But when a computer generates a perfectly structured 5-paragraph essay with a thesis statement and a nuanced conclusion, human psychology works against us.
We project meaning onto the blank screen.
Yes. Our brains are hardwired to attribute communicative intent to fluent language. We read coherence into the machine's output because we are applying our own human understanding to the text. The coherence is entirely in the eye of the beholder.
We're filling in the blanks.
Exactly, and the researchers warn that this illusion of meaning leads straight into automation bias, the human tendency to blindly trust the output of a machine simply because it sounds confident and authoritative.
The 2021 paper provides some pretty chilling real-world examples of automation bias going wrong, don't they?
They do, and they are stark reminders that these aren't just academic thought experiments. They cite a tragic case involving machine translation on Facebook. A Palestinian man posted a photo of himself leaning against a bulldozer. He wrote a simple caption in Arabic that translates roughly to "good morning."
A completely benign post.
Completely. But Facebook's proprietary machine translation system made a statistical error. When it translated the Arabic text into Hebrew and English, it output the phrases "attack them" or "hurt them."
Oh my God.
The Israeli authorities saw the translated post, trusted the machine's output, and arrested the man.
Just based on that translation?
Yes, they assumed the translation carried the communicative intent of the human who posted it. But the machine had no intent and no understanding of context. It simply made a catastrophic probability error, and an innocent person suffered real-world trauma because humans trusted the stochastic parrot.
That is terrifying. And beyond accidental mistranslations, the paper warns about deliberate misuse, right? Taking advantage of that fluent illusion.
They reference studies showing how these models can be used to mass-produce extremism. Researchers demonstrated that GPT-3 could easily generate text adopting the persona of a conspiracy theorist. It could invent fake, coherent-sounding Q&A sessions about extremist ideologies. The fear in 2021 was that bad actors could use this to flood recruitment message boards with thousands of fake personas, making vulnerable, isolated people believe they were interacting with a massive, like-minded community of human beings.
Because the machine has no moral compass. It doesn't care if it's predicting the next token for a cupcake recipe or a terrorist manifesto. It's just doing the math.
Exactly. And the ultimate warning of the 2021 paper is this. If the tech industry continues to pour all its resources into simply making these unthinking parrots bigger and bigger just to cheat their way through natural language benchmarks, they're not actually progressing toward true machine intelligence. They are just building more convincing illusionists, leading us all down a dangerous garden path.
Okay, we have laid out this massive, terrifying, practically unassailable wall of logic from 2021. The data is fundamentally toxic, the environmental footprint is catastrophic, and the very architecture of the system is just a statistical parlor trick that exploits human psychology.
It's a heavy critique.
It is, but I have to look at the calendar. It's 2026. This brings us to the pivot of our deep dive. Jorge Garapiri steps into the arena with his essay, and his first major critique of the stochastic parrot label isn't about the math, it's about the timeline.
Right. Papert demands that we look at the historical context of the debate. Bender and Gebru published their paper in early 2021. The technology they were analyzing was fundamentally different from what exists today.
A lot has changed since 2021.
Late 2022 was the inflection point. ChatGPT brought generative AI to hundreds of millions of users overnight. And in the years since, the architecture, the application, and the integration of these models have evolved at a blistering, unprecedented pace.
And Packers isn't just a Silicon Valley hype man, right? As we noted, he's a science writer, an independent researcher. He holds a Ph.D. in bioinformatics. He spends his life studying how complex, multi-layered systems interact, whether in a human cell or a computer network. He approaches AI from the perspective of how a holistic ecosystem functions.
Which leads to his central thesis: the technology evolved, but the public criticism stagnated. He argues that today, pointing at a modern AI ecosystem and smugly calling it a stochastic parrot has become an intellectually lazy cliché. Yeah, he says people use it as a badge of sophistication, a buzzword, to shut down a debate, so they don't actually have to do the hard work of understanding how the technology operates today.
I totally see his point. It's a lot easier to quote a 2021 paper than to learn how a modern system is actually engineered. But how does he dismantle the core logic of the parrot? Because earlier, we established that mathematically, the model is just predicting the next token. Doesn't that remain true?
Well, Papert acknowledges the mathematical foundation. Yes, at the very bottom layer of the software stack, a language model predicts tokens based on probability. But he argues that this low-level observation completely fails to describe the system that users actually interact with today. And to explain this, he introduces a brilliant analogy.
Oh, here's where it gets really interesting. I love this part of his essay. He says that calling the entire modern AI ecosystem a stochastic parrot is exactly like pointing at a modern commercial airliner and dismissing it as a machine that spins a fan.
It perfectly exposes the flaw in reductionist thinking. Technically, a jet engine does spin a fan. You have accurately identified a core mechanical component of propulsion.
Right, but that's not the whole plane.
Exactly. Practically, conceptually, you have utterly failed to describe the airliner. A Boeing or an Airbus is a massive, complex system that navigates via satellite GPS, dynamically pressurizes a cabin at 35,000 feet, calculates weather patterns, and executes automated landings. If your entire critique of an airplane is that it just spins a fan, you are missing the reality of the machine.
That makes intuitive sense. So in the context of modern AI, what is the airliner? What is the machine doing today that elevates it beyond just spinning the fan or predicting the next token?
Well, the AI systems of today are no longer isolated text generators living in a vacuum. The language model, the Parrot, is now merely the central processing hub for a vast interconnected array of functional tools.
Tools like what?
Modern AI actively searches the live internet to retrieve up-to-date facts, completely bypassing the value lock of its training data. It writes, tests, and executes Python code in isolated environments to solve complex mathematical or logical problems that probability alone couldn't handle.
Right, if I ask an AI today to calculate something complex, it doesn't just guess the next number. It literally writes a calculator script, runs the script, and gives me the exact answer.
Exactly. It interfaces with secure databases to retrieve legal documents. It orchestrates multi-step workflows. It uses agentic frameworks to break a large goal into smaller tasks, evaluate its own progress, and correct its own errors. The system is orchestrating action, not just generating text.
I have to push back here, though. Let's really stress test Pyre's argument. Isn't the core of the engine still just a parrot? Let's say the AI searches the web and hands me a link to a Wikipedia article. Isn't it just a parrot that probabilistically guessed that I wanted a web link?
I see what you're getting at.
Right, like if I take a literal parrot in a cage and I bolt a calculator and a search engine to the side of the cage, does it stop being a parrot? Isn't it still just manipulating form without ever understanding the meaning of the Python code it just executed? Does bolting tools onto a parrot turn it into something else?
That is a phenomenal question, and it's the exact tension Pyres anticipates. To answer it, he takes us on a detour into the history of computer science, specifically to show how AI has historically, repeatedly broken past theoretical limitations that critics assumed were permanent walls. He wants to show that judging an evolving system by its past limitations is a historical trap.
He brings up the goldfish memory myth to start, right?
Right. Think back just a few years. Early chatbots and language models had notoriously tiny context windows. They could only remember the last few sentences of a conversation. If you talked to them for 10 minutes, they completely forgot how the conversation started.
I remember that. It was so frustrating.
Critics mercilessly mocked them for having the memory of a goldfish. And in 2020, that was a completely valid, mathematically accurate critique of the architecture.
But the architecture didn't stay still.
Exactly. Engineers innovated. Today, modern architectures can process hundreds of thousands, sometimes millions of tokens in a single prompt. They can hold entire books, reams of legal code, or hours of conversation history in their active memory while they interact with you.
Wow, that's a huge leap.
They don't have perfect human memory, but continuing to call them goldfish today just reveals that the critic hasn't updated their knowledge in 3 years. But Pyres goes even deeper into history to make his ultimate point. He brings up the XOR problem.
Okay, we need to spend some time on this because Pyres clearly thinks understanding the XOR problem is crucial to understanding why critics get stuck. Walk me through what happened in 1969.
In 1969, the field of artificial intelligence was in its infancy. Two titans of computer science at MIT, Marvin Minsky and Seymour Papert, published a highly influential book called Perceptrons. They were analyzing the very first generation of artificial neural networks, which were very simple, single-layer systems.
Single layer, okay.
And they mathematically proved that these single-layer networks were fundamentally incapable of solving the XOR problem.
I know A and D gates and OR gates from basic logic, but what exactly is XOR?
XOR stands for exclusive OR. It's a basic logic function where the output is true only if the inputs are different. The easiest way to visualize it is ordering at a restaurant. A menu says you can have soup or salad with your meal. That is an exclusive OR.
Okay, so I can have soup, or I can have salad.
Right, but if you try to order both the soup and the salad, the waiter says no.
So it's a simple boundary. One or the other, but not both and not neither.
Exactly. It is incredibly simple for a human to understand. But Minsky and Papert proved that a single-layer neural network literally could not draw the mathematical boundary required to distinguish that logic.
So they mathematically proved the AI was too stupid to order soup or salad. How did the scientific community react?
They rejoiced. The critics of AI celebrated this proof as the ultimate insurmountable wall. They looked at this mathematical limitation and extrapolated that if a neural network couldn't even solve XOR, it could never achieve any complex, meaningful pattern recognition.
They just wrote it off entirely.
This critique was so devastating and so widely accepted that it contributed to what is known as the AI winter, a period where funding for neural network research practically dried up for a decade because everyone assumed it was a dead end.
It sounds exactly like someone proving a language model is just predicting tokens and therefore declaring it will never achieve complex reasoning. So how did the AI winter end? Did Minsky and Papert's math turn out to be wrong?
The math wasn't wrong. It perfectly described the limitations of a single-layer network. But while the critics were busy patting themselves on the back and writing obituaries for AI, the engineers didn't stop working.
They found a workaround.
They realized that if a single layer couldn't solve it, they just needed to add more layers. They quietly developed multi-layer neural networks, adding hidden layers of computation between the input and the output. With a hidden layer, the network could easily, trivially solve the XOR problem.
So the insurmountable wall was just a speed bump.
Today, teaching a neural network to solve XOR is literally a week 1 homework assignment for college freshmen in computer science. It is completely trivial. The fatal critique from 1969 was rendered utterly obsolete by architectural evolution.
That is a stunning parallel. Peirce is pointing out a repeating historical pattern here. Like, step 1, a fundamental limitation is discovered. Step 2, critics declare that AI has reached an absolute dead end. Step 3, engineers quietly build a new architecture that bypasses the limitation entirely, while the critics are still giving speeches about step 1.
If we connect this to the bigger picture, this is where Peirce leans into his background in science and philosophy. He notes that the scientific method is entirely based on updating your models when new data arrives. When Newtonian physics couldn't explain the orbit of Mercury, Einstein introduced relativity. We update our models.
Right. That's just good science.
But ironically, Peirce observes that modern critics of AI seem fiercely resistant to updating their mental models. They are clinging to the 2021 stochastic Parrot theory with almost religious dogma, refusing to acknowledge the multi-layered, tool-using architecture that has emerged since.
Think about your own job for a second. If someone judged your current skills based on a mistake you made on your very first day 5 years ago, would that be fair? Are we holding AI to a snapshot in time? Peirce is warning that if you haven't fundamentally reevaluated your arguments against AI in the last year or two, there is a very high probability that you are furiously criticizing a system that simply does not exist anymore.
Exactly. But this brings us to a crucial synthesis. Because if Peirce is arguing so passionately that stochastic Parrot is a lazy, outdated cliche, it's very easy to misinterpret him as a blind techno-optimist who thinks AI is flawless. He is not.
Right. I want to be clear about his essay. He explicitly states that AI has absolutely not solved artificial general intelligence. He doesn't think the machine is sentient. And he lists a massive number of severe ongoing problems with the modern AI ecosystem.
He is incredibly rigorous about what we should be criticizing today. He points out that hallucinations where the system confidently invents completely false information, they remain a massive structural problem.
Oh, definitely.
Reliability is still spotty. A workflow that succeeds today might randomly fail tomorrow. He highlights interpretability, the fact that even the engineers who build these multi-layered systems often cannot explain exactly why the AI made a specific decision.
So he's not saying stop criticizing AI. He's saying upgrade your criticism. Stop yelling at the fan spinner and start investigating the autopilot of the airliner.
That is the perfect way to phrase it. He demands intense scrutiny on issues of alignment, robustness, and algorithmic transparency. And this is where we can actually pull these two seemingly opposed sources together. If you look deeply, Bender and Gebru's 2021 paper and Peirce's essay are not mutually exclusive. They represent two different layers of necessity.
How do you reconcile them? Because they feel miles apart initially.
Think about the core of the 2021 paper. The Stochastic Parrots paper was a vital, historically necessary warning about the foundation of these models. Everything Bender and Gebru warned about regarding the raw data pipeline was correct.
The uncurated data sets, the bias, the environmental cost.
Yes, the uncurated toxic nature of the internet, the massive environmental costs, the danger of automation bias, those are all foundational realities of how you build a base model. They rightly demanded value-sensitive design and forced the industry to reckon with its carbon footprint.
So the 2021 researchers were absolutely right about the concrete slab the house is built on.
Yes, but Pyers is arguing about the house. He is looking at the application, the orchestration, and the capabilities of the modern ecosystem built on top of that foundation.
Okay, that makes sense.
The foundation might rely on probabilistic token prediction, but the complex system operating above it, the airliner, requires a completely different set of analytical tools to critique effectively. Good criticism requires maintenance.
It requires maintenance of thought. You can't just memorize a critique and consider the job done.
Exactly. Prayers points out the ultimate irony here. If you just repeat the phrase stochastic parrot to sound smart and shut down a conversation without actually engaging with the complex reality of how the technology has evolved, you are just mimicking a soundbite you heard somewhere else without understanding the deeper meaning.
Oh, wow.
You have, quite literally, become a stochastic parrot yourself.
Oh, that is devastating. And he's right. If we actually want to hold these massive tech monopolies accountable for the environmental damage they cause or the bias in their systems, we have to understand the technology as it exists right now today. We can't fight tomorrow's battles with criticisms from half a decade ago.
We have to keep our mental models agile. As complex systems evolve, our computational thinking and our philosophical frameworks have to evolve right alongside them.
So what does this all mean? We have covered an incredible amount of ground in this deep dive. We started by exploring the terrifying physical realities of 2021, the hundreds of tons of carbon emissions, the massive uncurated data sets scraping the darkest, most biased corners of the internet, and the philosophical horror of machines manipulating form without a shred of actual meaning.
And then we collided that with the reality of today, guided by Jorge Garipures, looking at a modern ecosystem that orchestrates highly complex workflows, uses external tools, and solved logical problems in ways that completely shatter the simple parrot label.
And synthesizing all of this forces us to ask a really profound question, not just about the machines, but about ourselves.
If our criticisms of machine intelligence have an expiration date, maybe our definitions of human intelligence do too.
Wait, expand on that.
Well, think about it. If a modern AI system can successfully orchestrate a multi-step workflow, write and execute Python code, retrieve relevant legal precedents, and synthesize massive amounts of data to solve a real-world problem, and it does all of this without fundamentally understanding a single word in the human sense, does that mean the machine is just faking it?
Right.
Or does it mean that understanding isn't actually as necessary for complex, valuable work as human beings always assumed it was?
That is a deeply unsettling, fascinating thought to leave on. Maybe as we build these complex systems, we aren't just learning how machines work. We might be discovering exactly how much, or how little, of our own deeply prized human intelligence is actually required to navigate the world. Thank you so much for joining us on this deep dive. Keep questioning the easy slogans you hear in tech, keep updating your mental models, and we'll see you next time.